Welcome.
Thank you.
Welcome to the ZEISS Innovation Talks, where we bring you our experts to discuss innovations in industrial quality solutions. Today with me here, Valentina, Head of Product Management X-Ray. Thanks for joining me here on stage. Would you like to say a few words about your person and what you have been doing so far at ZEISS?
Yes, of course. Thank you for introducing me. My name is Valentina, and I've been with ZEISS for 4 years, first in the US and then here in Germany. And my expertise is on X-rays and dimensional metrology.
Great. So now everyone knows why you are the expert here with me to talk today about the basics of X-ray, what are the industrial trends that X-ray helps to address, and the latest innovation that we bring to our customers. But before we go into this topic, I would like to do a small lightning round with you.
Okay.
That the audience gets the chance to get to know you a little bit better. So I hope you don't mind. Lightning, short and spontaneous answer. So let's start with the personal ones. First question, are you more the morning person or staying up late?
Staying up late, for sure.
Okay, appreciated that you came this early this morning. Pizza or pasta?
Pasta?
Oh, I would have expected both, as you
Because
have
I'm Italian, right?
Italian
Yeah.
heritage. Okay, now we come to the hard technical ones. If you think about application, would it be metrology or inspection?
Metrology. But
Based
that's very...
on your background.
Yeah, based on my background, but that's a very difficult one because, also the inspection, it's really...
Okay, and now comes the really difficult one. If you can't choose metrology on X-ray, would you rather choose tactile coordinated measurement systems or 3D scanning?
3D scanning, but simply because my background actually is on CMMs.
Okay, so then I guess this was a hard question, but it's a nice introduction to our portfolio. Today we will start with the X-ray topics, and yes, I guess we go back a little bit to the basics of X-ray technology. People might know it from the dentist or from the doctors, but how is X-ray used in the industrial settings?
Yeah, so the technology is somewhat similar to the technology that is used in the medical field. We have an X-ray tube, we have a detector, and the concept is based off of the attenuation of X-rays
So
through the part.
attenuation means just absorption of...
Yeah, so the X-rays go through the part, they interact with the part. There are some physical interactions that take place, and then we record through the detector, essentially the X-rays that go through the part and then are attenuated by the part.
And then this gives us a 2D image of our part that we can capture.
Yeah, absolutely. So there are, let's say, a variety of applications, and I would actually group, our portfolio into 3 areas. So we have the 2D imaging, industrial radiography, where, as you mentioned, we acquire one or multiple 2D radiographs. Then we have X-ray computed tomography. Typically, we refer to it as X-ray CT, where we acquire a sequence of these 2D radiographs.
And a sequence means different angles, or what is...
Yeah, absolutely. Different rotation angles. And then these radiographs are reconstructed into a 3D model of the part, which is actually the basis that then we use to perform inspection tasks, dimensional metrology.
And is it correct to assume that then the 2D has a resolution and 3D gets even better because we have more data? How far can we push this resolution topic in our CT world?
Yeah, so with the CT, we can get down for sure to a few microns. To push it even further, we have the X-ray microscopy.
X-ray microscopy, okay, this sounds interesting.
Yeah, so there we can leverage also, among other things, the optical magnification, which enables to bring the resolution even at higher levels. So
higher means for submicron applications in electronics, or where is this useful?
Yeah, typically also in the field of electronics. Nowadays, we can think about batteries.
Okay.
Yeah.
Okay, that's interesting. So then this puts us into the second topic that we want to discuss. So what are the trends in industry where X-ray is really helping, or where we see X-ray flourishing for our customers?
Yeah, so the applications are really broad. And of course, we hear a variety of requirements coming from specific markets, but also some requirements which are let's say, universal across the different applications and markets. One requirement that comes to my mind is related to the trend of megacastings and gigacastings.
Okay, so what does mega and giga means? What can we imagine as the dimensions?
Yeah, so there typically we're looking at parts which are bigger than a meter and a
Okay,
half.
that's huge, yeah.
And yeah, there the requirements call for automated inspection of these megacasted or gigacasted parts, specifically looking for defects in the part.
Okay, and you explained that we do those images basically by moving the objective and not the source and the detector. But if these parts get so big, how do we do this inspection?
So in that case, we're using 2D imaging, so industrial radiography. And there we have the capability to move the source, to move the detector, but also to move the part through a sophisticated mechanism that enables us to move the part.
Sophisticated because it needs to be coordinated?
Because we have various degrees of freedom on the, let's call it, manipulator in order to achieve the movements that we want to achieve. And in this way, we can acquire the radiographs that we talked about before at different angles in order to ensure that we inspect the part in all the regions that must be inspected.
And if you say inspection, so we get a 2D image and then someone needs to judge what the defect is. How is this analysis part done?
Yeah, in that very specific case, you're bringing me to another very important trend. So in that specific case, we're using ADR, which stands for automatic defect recognition.
So what is the automatic in there? Is this a machine learning algorithm? Is it a trained human-based algorithms, or what does automation mean?
There are different options. In this case, we're using non-machine learning-based algorithm, but we also have other options too, where we're using machine learning-based algorithms as well.
But automation means no human involved anymore, and you have a high speed, or what is the accuracy better? Is the speed better? What is the benefit of having this automated?
Yeah, so the automation comes in, as you mentioned, for a few reasons. The speed, because we can automate the inspection too, but also when it comes down to data quality, AI, for example, can be very beneficial because we want to bring the speed up. And we want to have always shorter and shorter cycle times. And of course, it's always a compromise, between the image quality and the speed.
You can't get both?
I mean, ideally, yes. But, it's sometimes you need to compromise. And in order to have higher speed, the image quality can decrease. And in that case, AI, for example, can be very beneficial because we can train a model to detect, for example, the defects that we want to detect. And in that case, that can help extremely also with data sets where the image quality is intentionally not the best that we can get because the focus there is on the speed.
Yeah, and I guess that whenever I understand correctly, the gigacasting parts are used in automotive, but also in machinery. What about the dense materials that we see used in aerospace or medical industries? How do we deal with this, or is there a specific challenge?
Yeah, so of course, also there, the requirement of inspecting newer materials, denser materials, also requires us to bring in a new technology. So in this case, a very good example is the new system that we developed, the Matrotome 800 320 kVs, where we have a more powerful tube.
Okay, that's the 320 kV that refers to the tube and how much power it can really get, because this is related to the penetration.
Yeah, so the 320 kVs, that's typically, the power is also important, but typically the kVs are the ones that are important when we talk about the penetration.
Acceleration of the electrons going through the...
Yes, and this is a completely different application than the one that we were discussing just a few seconds ago. In the sense that, especially with the medical parts, we also receive requirements that lean more towards the metrology. Yeah. Because obviously with CT, we can inspect internal features and external features without any need to destroy the part because it's a non-contact technology.
And they usually have, like in the turbine blades, internal cooling structures that you cannot get with any tactile or optical system. You need the X-ray to really inspect those.
Exactly. So we don't need to destroy the part whatsoever.
And you mentioned that all these regulated industries, of course, have a high need of doing those inspections and metrology. And how do we speed up this whole process in order to enable this, not just in the quality, but maybe also in the production? Because In medical, you sometimes have to do 100% inspection and metrology.
In that case, there are, I guess, different areas where, these improvements or, these challenges can be tackled. One very important trend is relative to automation. And,
so automation at what point? At the imaging?
Yeah, that's a very good question. It can happen, actually. Automation can be, it's a more general term, but it can be applied to different, let's say, stages of the workflow. We could have, let's call it hardware automation, where perhaps you could have a robot loading parts inside the system. Or then, in combination with that, we can also have software automation, where, for example, the metrology tasks or the inspection tasks are then automated through the software.
So this means we tie everything together, the part handling, the loading, the imaging, the data analysis, even the reporting. Is this all part of our...
That can also be part of, the one unique workflow where the only thing that the user needs to do is starting the program.
Okay, this sounds really like enabling the shop floor applications for X-ray. Thanks for sharing. We know that you mentioned this at the very beginning. There's a huge variety of services and applications that we are serving our customers with. How do we keep track of all of those applications, and how do we adapt all those tools to the specific customer needs?
Yeah, of course. There are so many requirements coming from so many different industries, and that's all the job that we need to do to ensure that we funnel these requirements into our product development and actually keep in mind the whole package as you described, because especially, overall, but especially when we talk about automation, you can imagine that, aspects such as the uptime, the service, the maintenance, the overall serviceability of the machine are really of paramount importance. And it doesn't really end there, because, the application, as you refer, this is really, really important. And having the ability to not only manufacture the systems, provide the software that goes with those systems, the software to analyze the data, but also have the overall team, to take care of the applications with our application experts. This is really important. So
with this, we can even tackle the most difficult challenges. If I now think about one that came lately at a customer, it's automotive electronics, where they have to do a lot of failure analysis or inspection tasks, but it gets really challenging because you don't have this one material like in the aluminum casting that we discussed. You don't have the turbine blade material or the knee implant. So how do we deal with this challenge that I have seen at a customer for multi-materials that usually creates, a difficult life for application to really get some good metrology or inspection data?
Yeah, you're right. It can become challenging with multi-materials because we have two or more materials with different density. For example, lower density for polymers and higher density for metals. And let's say the combination of these two can create some artifacts.
So what kind of artifacts is this?
Artifacts are like structure which are present in the image, but they're actually not existing.
Okay.
The case scenario that you mentioned, there could be some streaks, like really some streaks that you see in the image, which can be created by the metal.
So it's not real, it's just...
It's not real.
Okay.
It's like an artificial, there can be some artificial structures. And with that regard, we have some software corrections that we can implement. And in this case, we have what we call the two-material beam hardening correction, which is available in ZEISS Inspect X-ray.
And when you hear it's a software correction for a hardware problem, so you have to understand very nice the correlation of your system and all the hardware, how it's built, in order to correct it efficiently, or...
Yeah, in this case, it's actually a physics
it is a physics
topic.
problem that
Yeah,
we solve.
because it's not really created by the hardware. It's a physical effect that happens. In this case, through the software, we can correct for some of these artifacts. But then we have other examples too, actually, where it's a combination of hardware and software. For example, scatter artifacts are also other artifacts that can appear. And in this case, we have a combination, as I said, of a module, which is like a physical module.
Physical
it's like
thing that we put into the beam in order to avoid those scattering.
Exactly. In our case, our solution is the scatter control.
Okay.
And then in combination with the software, we can correct for these scatter artifacts.
Okay, so this sounds complicated, but I guess the result is quite easy because you get a perfect image.
It sounds complicated, but it is not, because typically these solutions are really easy to be used by the user.
And I think this is really the key to end on. Easy to use for the customer. And I understand we have solutions on the 2D X-ray side, really for casting. You mentioned this. We have the 3D for metrology and inspection tasks, X-ray microscope for the really high-end resolution electronics failure analysis modes. And of course, everything is tied together with the software that runs those systems. Any other point you want to give for the audience as a small summary?
Yes, for sure. I guess the one message that I want to convey is that the X-ray technology in general can be really beneficial across, let's say, different stages of the product life cycle. Not only the R&D, not only the production, but really the overall, product life cycle stages. And then the other aspect is, for sure, it's important for us to really push the technology and push really the boundaries. And also, looking at applications that are really innovative and really new. So we really want to focus our attention there.
Yeah. Valentina, thanks for sharing all those insights.
Yeah, it was a pleasure.
Thanks to the audience for tuning in. So this was the ZEISS Innovation Talks on X-ray. Stay curious, keep innovating, and see you next time. Thank you.
Thank you, Robert.